So for the cooling loop, we have a system drawing here, and you can see we have a return air coming in here and our supply air going out here. Our supply air temp is going to be on the supply side, obviously right after the chilled water coil. Chilled water coil has two lines coming in, the chilled water return and the chilled water supply. There is a chilled water cooling valve on the return side that would help flood this coil over here, hopefully get some better dehumidification. We have a supply fan directly before the chilled water coil. We have a VFD hooked up to our fan. We are not actually covering that, but our supply fan start-stop goes through that VFD. We do have a fan status, which is actually a pressure switch on the side of our supply fan. And then right down here we have our control, and we have a unit enable switch, which is just a simple toggle switch that tells the control to turn everything up here on. So for our cooling and fan loop, we have a control right here is this box. We have a cooling valve over here, which on the unit it is connected to ITB1 terminal block. It's going to be hooked up to spade terminals 1, 4, and 5. 1 is going to have 24 volts going to it, 4 is going to be our common, and 5 is going to be our analog output number 2. That's going to be the control for our cooling valve to tell it when to open, when to not. As I said, we have a supply fan that is included in the VFD, but it is hooked up to binary output 1, and it also has a common. Our unit enable switch, just a toggle switch, is hooked up to input 4, and it has a common. Supply fan status, as I said, it is a pressure switch. The pressure switch and the supply air temp are both hooked up to ITB terminal block 3. The supply fan status is going to be hooked up to spade connections 3 and 5. That's going to be input 5 and common. Supply air temp is going to just be a simple resistor. It is going to be an averaging resistor, so it's going to basically take up the entire spot. It is hooked up to terminal spades 5 and 6, and that is input 3 and common.
So your system will run off a unit enable switch, and as you can see here, it is enabled to run on. Your unit enable switch is right here. And here are all your inputs. You got your AO1s and your inputs here, your BOs up here. And then here's where your fan comes in. And over here is your chilled water valve. And that'll maintain your set point of 55 degrees.
Alright, so we're going to talk about the supply fan start-stop override, which is a binary output. So if you want to override, we go to this panel here. We're going to hit override. We're going to go, we have 3 options. We're going to go to override a binary output right here. We're going to have 4 more options. We want to go to VFD enable right here. And then this right here, these 2 options we want on, and it'll ask if we want to change, but for the sake of this video we're just going to say no, we don't want to change. And it's as simple as that to override your start-stop for your binary output fan.
So this is your cooling valve. This top part here is the actuator. The valve is actually down here under this insulation. So this is, if you take power away from this, it's going to automatically open, but if it does get stuck in the closed position or anything like that, you can remove the power, and then you just stick your Allen key in here and you twist it either way to your desired position, and it'll stay right there, and then it'll either be open or closed, and you can leave the power off until you figure out what it is. If for any chance you try and turn this, and even if you go like this and it doesn't want to turn, it's probably seized up, and I would avoid breaking it, and then see about getting a new actuator. Stop it. Stop it.